So in this video, we're going to see that same equilibrium system we saw before, where we've got these cobalt equilibrium systems. And what we're going to do is we're going to put one of them in a hot bath and one of them in a cold bath. And we're going to try to decide, based on the evidence, is this reaction endothermic or exothermic? So before we show you the evidence, because this is a place that's really easy to get confused, if this reaction is endothermic, the energy is written as a reactant, right? And so if I heated up a system that had energy as a reactant, the system would shift this way. So if it's hot, I expect the equilibrium to shift this direction if it's endothermic. And if it's endothermic, I would expect that as I cool the reaction, it would shift this way, right? Because it's got to replace the energy that's being removed. If instead the equilibrium system is exothermic, then energy is a product. And if energy is a product, as I heat it, the energy needs to be used up, and it would shift this way to use that energy up when it's heated. If it's cooled down and it's exothermic, then I expect that the reaction would shift this way to replace the energy removed, right? Because if it's cold, they're removing energy. The equilibrium would shift this direction. That's if it's exothermic. So really, which direction it shifts when it's heated and cooled depends on if the reaction was originally endothermic or exothermic. So now, the results of this reaction are that as it is heated, it becomes more blue. And if it's cooled, it becomes a lighter pink. So if I had energy here and I heated it up, it needs to shift this way to use it. And that's what we see here. We get a more blue color because the energy is being used up. We've heated it and it's being used up. Whereas when we are cooling it down here, we are cooling it down, we've removed energy, so now it needs to shift this way to replace the energy that was used. And it's because this system is endothermic or exothermic. One place where people sometimes get a bit confused are they think that it's endothermic or exothermic based on whether it's in ice or in hot water. But really, the reaction is either endothermic or exothermic, and the energy will be replaced if it's in a hot environment. It'll be used if we are heating it up, and it'll be replaced if it is being cooled. Hopefully that helps. This tends to be one people get confused on.